Hi everyone, today we are looking at chemical monitoring and management, and today we will be looking at the first-hand investigation identifying cation and anions in anion mixtures. So you should perform this experiment at your school. So we will today look at what methods you can use to perform this experiment and also what sort of results you should predict. So let's look at step 1. In step 1 you should add nitric acid, and you should also put your solution in a water bath so that to keep it warm. And so the first step is to add dilute nitric acid. And what happens if you do that? If you add dilute nitric acid, bubbles should form. So as you can see in this animation, you add nitric acid and then there should be bubbles, and that indicates that carbon dioxide is present and also indicates that carbonate ions are present in your solution. Now step 2 would be you take that solution and you add barium nitrate. Now when you add barium nitrate, what will happen? So if a white precipitate forms when you add barium nitrate to your solution, it will indicate that sulfate ions are present. Again, when you add barium nitrate, you can see there is a white precipitate formed, and that indicates that sulfate is present. Now you need to filter the solution, your previous solution. Why do you do that? Just to ensure that your solution does not get contaminated. Also, so that you can get rid of your precipitate and you only have a liquid solution in as your testing sample. You need to filter the solution. So after you filter the solution, you need to add silver nitrate to the acidic filtrate. And why is it acidic? Because if you remember, you already added nitric acid to your solution. Therefore, you will have acidic filtrate, and then you add silver nitrate to it. And what happens then? If you get a white precipitate, it should say that chloride is present. So again, when you add silver nitrate to your solution, a white precipitate should form. That should indicate that you have chloride anion present in your sample. Now step 4 is again, you filter the solution to get rid of your precipitate so that it does not contaminate or hamper with the next stage. So you filter the mixture and make the filter alkaline. So to make it alkaline, you should add lots of ammonia to it. So you add ammonia to it and the pH goes to 9. And then you can add barium nitrate to the solution. And when you add barium nitrate to the solution, if a white precipitate forms in an alkaline solution, then it indicates that phosphate is present. So you make alkaline by adding ammonia, and then barium nitrate should form a white precipitate, indicating that phosphate ions are present in your solution, as you can see in the animation. So let's move on to the next step. The next step is to confirm that it is phosphate. You can use a fresh sample and add silver nitrate solution to it. When you add silver nitrate solution to it, silver phosphate should form, which is a white precipitate, again confirming that the anion present is phosphate. And also a yellow color, if you add a yellow precipitate is formed, that also indicates that phosphate is present in your sample. Now let's look at some cation mixtures. So what happens if you have cations in your solution, not anions? So first you add hydrochloric acid, and if a white precipitate forms when you add hydrochloric acid, it indicates that lead is present in your sample. Again, you add hydrochloric acid to it. You can see in the animation that a white precipitate forms as soon as you add the hydrochloric acid, indicating that the cation lead is present. And to confirm that lead is present, if you add sodium iodide to a fresh sample, an intense yellow precipitate forms, which again indicates that it's lead. Because if you can remember from your theory that lead iodide is a yellow compound, and in the solution it should appear yellow. Now again, you need to filter your solution to get rid of precipitate so it doesn't contaminate or hamper with your next step. And after you filter the solution, you should add sulfuric acid to it. What happens then? If you add sulfuric acid to your solution and a white precipitate forms, it will indicate that either barium or calcium is present. So when you add sulfuric acid and it gives you a white precipitate, you can be sure that either of these two cations are present, either barium or barium or calcium. But how do you know which one, whether it's barium or calcium? So to do that, you need to perform a distinguishing test. So what you do is you add sodium fluoride to a fresh sample. So if you add sulfuric acid and a white precipitate forms, it's either of these two elements present, and to make sure which one of the two elements are present, you add sodium fluoride. Let's look at what happens if we add sodium fluoride. So if we add sodium fluoride and a precipitate forms, as you can see in the animation, it indicates that calcium is present. And what happens if no precipitate forms? So if no precipitate forms, it indicates barium is present. So when you add sulfuric acid to your solution and a white precipitate forms, it indicates that a calcium ion or barium ions are present. And to confirm or to distinguish which of the ions are present, if you add fluoride to it, if white precipitate forms, it indicates it's calcium, and if no precipitate forms with fluoride, then it indicates that it's barium. Also, you can use a flame test to distinguish between calcium and barium, because we know that calcium forms an orange-yellow flame color, whereas barium forms a distinct pale green flame color. So if you don't want to carry out a precipitation reaction to distinguish between which of the cations you have present, you can always carry out a flame test, which will indicate that calcium is present by an orange color or barium is present by a pale green flame color. Now let's look at what we can do in steps 3. So again, you need to filter your solution so that no precipitate contaminates your next step, and then you add sodium hydroxide to your solution. And what happens then? If you add sodium hydroxide and a blue precipitate forms, if you can see in the animation, it indicates that copper ions are present. So copper hydroxide is a blue compound. So the precipitate formed in your test tube should be copper hydroxide if it's blue. And if a yellow precipitate forms, then it indicates that iron 3+ is present. So if it's blue, it's copper. If it's yellow, it's iron. To confirm copper, you can also use a flame test. So when you put copper in a flame test, a brick red color should form. But then again, if you want to distinguish between iron and copper, the best way to do that is to use the precipitation test, because you know that both of these produce a distinct color with hydroxide. So this would be the best test to perform to distinguish between copper and iron. But just in case, if you want to conduct a flame test, you can do that just for copper, because iron does not have a distinct color with flame, but copper does, which is brick red. So you can use that to distinguish that copper ion is present in your cation, as your cation in your solution. So let's look at the distinguishing test for iron. The distinguishing test for iron is you need to add potassium thiocyanate to your solution, and when you do that, a complex should form, which is red in color, and the complex is iron thiocyanate, and iron thiocyanate again indicates that iron 3+ ions are present in your solution. So a distinguishing test for copper would be a flame test, whereas a distinguishing test for iron should be by adding the mixture potassium thiocyanate, and the complex ion that forms should be red in color. And that tells you that iron is present. This brings us to the end of this investigation. Now let's look at some of the questions to test your knowledge. So question 6 tells us, describe chemical tests to identify the carbonate anion. Write ionic equations for all reactions to describe. So we need to perform a test that will indicate carbonate anions are present in your unknown sample. So what do? So first you can add nitric acid to your unknown, and bubbles of gas were observed. So when you add nitric acid, you should see bubbles of gas coming out of your solution. Now those bubbles of gas actually indicate that carbon dioxide is present, and that will also indicate that carbonate ions must be present. So let's look at the equation. So what reaction occurs? So carbonate ions plus acids. So acid can be represented with an hydronium ion, so which is H3O+. So carbonate plus hydronium ion gives you carbon dioxide gas. So you can see bubbles of carbon dioxide gas in your solution, and it also produces water as one of its products. So this brings us to the end of question 6. And in question 6, you can see to identify the carbonate anion, you can add nitric acid, and if bubbles of carbon dioxide are formed, it indicates that carbonate ions are present. Now let's move on to question 7. Question 7 tells us to describe chemical tests to identify the chloride anion. Write ionic equations for all reactions you describe. So what happens if you want to test if your solution has chloride anions present? So let's see what steps we can take. So a solution containing silver ions, so such as silver nitrate, you can use silver nitrate as your testing solution. So if you add silver nitrate to an anion and a white precipitate forms, it will indicate that chloride anion is present. So your testing solution should be silver nitrate, and you add it to your unknown, white precipitate forms, chloride is present. Let's look at the equation for that. So the equation for that is silver plus chloride forms silver chloride solid, which is a white precipitate. And also, if you take the precipitate and put it under sunlight, such as UV light, so you know sunlight contains UV. So if you put it under UV light, it should change its color. So what happens is this reaction occurs. So the silver chloride actually dissociates into silver solid metal and forms chlorine gas. You can obviously see the chlorine gas, but the silver solid metal appears as a black solid in your test tube. So that again indicates that chloride was present because it goes under this reaction. And you can see a black precipitate, which indicates that silver is present. This brings us to the end of question 7. So what did we see in question 7? That if you have a solution and you add silver nitrate solution to it, precipitate should form, and if it's white, it's chloride. And how can you further confirm that it's a silver chloride precipitate form? If you take it outside under sunlight and UV light hits it, then the silver chloride should dissociate and silver metal, which is black in color, should form, and chlorine gas should be released, but you can't really see the chlorine gas. Now let's move on to question 8. Question 8 tells us sodium chloride, calcium chloride, and sodium carbonate were left in unlabeled beakers, colorless solutions. Describe how the student could identify its solution. So we need to perform tests that will help us distinguish whether the solution was sodium chloride or calcium chloride or sodium carbonate. So let's look at some of the tests we can perform to see which solution was in which beaker. So first, if we add silver nitrate to a solution and a white precipitate forms, it will identify that chloride is present. And how do we distinguish between the chlorides? The carbonate can be confirmed by addition of an acid, because we already know that if we add nitric acid to a solution and bubbles of gas are produced, those are actually carbon dioxide, and that will indicate that carbonate ions are present. So the carbonate can be confirmed by addition of an acid, such as nitric acid, and the gas that's formed, so the carbon dioxide that formed, if you put it into lime water, then it should create a milky white color. And if your solution turns milky white, it again indicates that carbonate ions are present. So the two chloride solutions can be distinguished by flame tests as well. So as you know, sodium will produce a different flame color to calcium, because sodium produces an orange-red color, whereas calcium produces a brick red color. So these are the two ways you can also distinguish between two of the solutions. And how can you say that calcium is present? So calcium again produces a brick red color, whereas sodium produces an orange and yellow flame. So this is how you can distinguish between these three solutions in your beakers. This brings us to the end of the questions session, and in this investigation you looked at how different anions can be identified in your solution.